So we're going to go ahead and get started so we can stay on track. So today starts our research presentations. And I sent out exam questions for the ones I had. As soon as I get all the rest, I'll resend that document. So hopefully by the end of the day, I'll be able to resend that to you with all of those. So today we have Kate Reed, Robert, and Joe. Y'all know the schedule. We'll just go like that. If you have a Mac and can do Apple TV and know how to broadcast it here, that's fine. If not, it's probably the easiest thing is to email the PowerPoint to yourself and then just pull your email up on there, and that way we can go with that. All right, Kate Reed, take it away.
Okay, so I'm starting off with an article by Eagleman and colleagues in 2008 titled "Sleep Loss Produces False Memories." So the first thing you want to know about memory when considering this article is that human memory is not perfect and it's not a literal representation of what you're experiencing in reality. It is influenced by knowledge representations that already exist in the brain. So you can kind of think about this like top-down influences that occur on your memory. As far as the literature goes, what is known about sleep and false memories before the beginning of this presentation is that false memories are semantically strongly associated to actually encoded events, which means that false memories are related to reality semantically as opposed to visually or in a tactile sense. They have strong associations to words and the meaning of words. Another thing to consider is that sleep promotes false memories during memory consolidation, and this has been shown in the literature. Sleep promotes false memories during memory consolidation by not only strengthening neural circuits as we sleep and replaying those memory circuits, but also relocating them into long-term memory areas in the brain. So when you relocate them, you reorganize them, you reintegrate them into different areas, and therefore memory can be essentially false in this way. Another way that promotes false memories is loss of sleep. And loss of sleep promotes false memories via dysfunctional encoding. You can think of this like we know that sleep deprivation impairs cognitive functioning. Sleep deprivation impairs attention. Sleep deprivation impairs motivation. So in this way, as you're experiencing reality, you may not be paying enough attention or be motivated enough to encode these memories correctly. Another thing that this article investigates is the underlying mechanisms of false memories. In this class, we've talked about adenosine as a sleep pressure. And this study also concurs with that theory. Basically, adenosine builds throughout the day, and when you start to feel sleepy, the emergence of sleepiness is caused by adenosine, and is also the underlying mechanism of impaired cognitive function when you're tired or when you've been awake for too long. Okay, so this article, this is a great graph of the methods. In this article, we have 4 experiments. I'm not going to go over all of them because I think that, well, the methods for them, I am going to go over all the experiments, but I think that the methods will make more sense in the context of the results. So we're going to start with experiment 1. Here you can say we have 3 independent variables and 1 dependent variable, which is the false memory rate. We have 3 conditions. 1 is night wake, which was sleep deprived, if you're awake during the night. Night sleep, getting a restful night of sleep. And day wake, where you are learning in the day, staying awake, and being tested at the end of the day, but not being sleep deprived because you weren't awake over the night. So we see here that night wake or sleep deprivation increases the false memory rate significantly as opposed to night sleep or day wake. And you can also see here that night sleep that consolidation or sleeping after learning is not critical for the production of false memories. Does that make sense? It'll be highlighted over and over in the next couple of experiments. So they wanted to elaborate on this idea in experiment 2. Here you have the same dependent variable, false memory rate, and here you have two controls, second night wake and second night sleep. Both groups received sleep the first night, which was consolidation, sleep after learning. However, one group was sleep deprived upon retrieval and testing, and the second group was not. So here you can see that when you're sleep deprived upon retrieval, even after you got good sleep during consolidation, you have a higher memory rate as compared to the second night sleep. So from this you can understand that false memories increase under sleep deprivation at retrieval, and that consolidation is not critical for false memories. In experiment 3, same dependent variable. We have two conditions. First night wake, which means that they were sleep deprived after learning. They did not get to consolidate their memories during sleep, and one group that did. However, both groups were rested at retrieval, so they were not sleep deprived at retrieval, but only one was sleep deprived during consolidation. And you can see that this doesn't really have a significant effect on false memory production. And then lastly, this is the experiment where they were exploring the mechanisms underlying false memory as adenosine. They use caffeine to do this because caffeine is an adenosine receptor antagonist. So, same dependent variable, two independent variables. Here we have two groups which were sleep deprived. One was given a placebo and another was given caffeine. Here you can tell that the group which received caffeine even after being sleep deprived had a significantly lower rate of false memories as compared to the individuals who were given placebo. So the conclusion across the first 3 of these studies, and this is important, this is what they were trying to control for many different things to prove it over and over. But essentially, sleep deprivation at retrieval critically enhances the rate of false memories, whereas sleep after learning, or lack thereof, which is the consolidation phase, did not enhance false memories. It had no effect. And the question you might ask yourself is why? Why does this make sense? And the article tries to provide some explanation for this. One is really what is a false memory. The literature suggests that false memories, like I said, they are strongly semantically encoded. But basically what occurs when you have a false memory is you're relying on the gist of a memory. It's not that you made something up completely, but something semantically strongly associated, you are basically encoding and retrieving the gist of a memory. And this might be adaptive in situations of restricted cognitive control, aka when you're sleep deprived. And then, what are the implications of caffeine and false memories? Why does this make sense? And why is it suggested that adenosine is an underlying mechanism of false memory? Well, first, the literature shows that decreased prefrontal activity increases false memory recognition, and this is opposed to recall. But prefrontal activity is decreased during sleep deprivation, and this makes sense. Caffeine blocks this inhibition or this decrease in prefrontal activity in the prefrontal cortex, And so this also makes sense why caffeine would decrease false memory. Secondly, caffeine increases arousal in attentional resources, and we know this as college students. The way that this interacts with false memories is that false memories occur as a result of decreased attentional resources at retrieval. And so if you're consuming caffeine, that would also stop those effects. Does anyone have any questions?
So any questions?
So when they say consolidation versus retrieval, is it depriving sleep the night after they did the retrieval task? Is that what they mean?
Night one, okay, so basically, maybe I should go back to the methods. Okay, so night one, this period here is considered consolidation. When you have learned, you go to sleep, you consolidate your memories, and then you're tested. But night two, if you're sleep deprived before testing, you're sleep deprived at retrieval. Does that make sense?
Okay, so retrieval is after.
Retrieval is after consolidation.
Because if it was before, there could be alternate explanation for why.
So the take-home message is that consolidation happens regardless of whether or not you have wake or sleep. But if you are sleep deprived, if you're awake, it makes it harder to retrieve, but consolidation happens.
Yes, exactly. And you can see this, I think, most clearly here, where both groups received sleep at retrieval. But their consolidation was interfered with, yet they have the same false memory rate. Any other questions?
All right, thank you, Kate. Robert, you are up. And if you guys will send me a PDF of your slides, then I'll post them on the Moodle page for everybody.
One second, I don't think this really has an applicant.
Yeah, it's on there. This is not on that screen. Three, 2, 6, 3.
Okay, so today we're going to be looking at the effects of cortisol on nocturnal memory consolidation. So the question to keep in mind today for today's presentation is describe the changes in cortisol concentration over the course of the sleep cycle. How is declarative memory consolidation affected? Note the effect of cortisol on specific brain structures. So let's first go over some background information to keep in mind. Number one, it's a commonly accepted fact that sleep facilitates the consolidation of memory. This has been displayed by the fact that when animals are taught a new skill or task, if their sleep is disrupted that night, they're less likely to retain that new ability. And also keep in mind that sleep can be divided into 5 stages. Stages 1 and 2 are very light sleep. You can be easily awakened. Stages 3 and 4 are considered deep sleep, and it's categorized by slow brain waves. There's a lot going on with slow brain wave sleep, so that's important to keep in mind for our literature. Both of these, or all 4 of the first stages, really are categorized by lowered levels of arousal. You're going to see cortisol levels decrease. You're going to see glucocorticoids and secretion slow down. But then the 5th stage is REM sleep. And in this stage, you actually see the brain at higher levels of arousal. And even some regions of the brain are more metabolically active during REM sleep when the patient is awake. Also in REM sleep, we see the limbic system activity increases, and at the same time, the frontal lobe activity decreases, thereby disinhibiting the limbic system. So looking at the article now, how exactly do these various levels of cortisol throughout the night affect the consolidation of the brain? So to answer this question, the literature actually broke it into 4 different pieces and used a separate related study for each piece. So looking at study 1, we're comparing procedural memory and declarative memory. Procedural memory, keep in mind, is skills. Think of the ability to ride a bike is procedural memory. Declarative memory, on the other hand, is more factual information and episodic memory. In general, procedural memory benefits from REM sleep, and declarative memory generally benefits from short-wave sleep. Declarative memory can be further divided into neutral and emotion-related memory. And specifically, amygdala-related emotional memory actually is enhanced by REM sleep rather than just simply short-wave sleep. And so study 1 compared the retention of neutral and emotional texts following short-wave sleep and REM sleep in healthy students. And what they found was that retention of neutral text was superior in participants following short-wave sleep, but the retention of emotional text was actually equal. And so this would imply that both the hippocampus and the amygdala play a role in the consolidation of emotional memory. So to further elaborate on this point, study 2 wanted to compare the emotional valence of pictures prior to and following both short-wave sleep and REM sleep. Essentially, patients were presented with an emotional image. They were asked to read it, and they were presented the same image and asked to read it again following either REM sleep or short-wave sleep. And what the study found was that following REM sleep, participants reported that the images were more emotional or had higher emotional valence than prior to sleep. And what could be causing this difference? Well, we look at the pituitary adrenal activity. During short-wave sleep, the pituitary activity reaches nadir or minimum. Active inhibition of cortisol due to circadian rhythms. But during REM sleep, however, this system becomes active. Plasma cortisol and acetylcholine concentrations actually raise, which increases our level of arousal. The question still remains, however, to what extent does cortisol feedback affect memory formation during these different stages? So study 3 essentially wanted to look at what would happen if we added cortisol to the system. So The researchers injected a low dose of cortisol into patients during either shortwave sleep or REM sleep. And what they found with declarative memory is that infusion of a low dose of cortisol during periods of shortwave sleep completely blocked hippocampus-dependent declarative memory. In comparison, procedural memory, when we talk about procedural memory for these purposes, they're using the mirror tracing task as a measure of procedural memory. If you're not aware of the task, it's participants are asked to trace a shape like a star, and they can only see their hand through the reflection. And the more you do it, the better you get. So it's a good indication of whether they're going to do better. But there was no effect of adding cortisol on procedural memory. And so these two things would indicate that there's a negative effect of cortisol on declarative memory. Specifically, it's interesting that while declarative memory formation was, or consolidation was affected, shortwave sleep itself was not, delta waves were still present. So this would mean that the cortisol would be directly affecting the hippocampus. And so the mechanism that would likely be responsible are glucocorticoid receptors. And to test this hypothesis, they applied a GR agonist, dexamethasone. And GR activation through this agonist led to profound impairment on declarative memory similar to cortisol itself. Once again, however, the procedural memory is not affected. So this would mean that inhibition of cortisol secretion is critical for the hippocampus-mediated formation of declarative memory. And during the first few stages of sleep, the central nervous system glucocorticoid receptors have to be inhibited. And so now that we've looked at what happens when we add cortisol to the system, researchers next want to look at when we remove it. And so to do so, they used a cortisol inhibitor so to again observe the effects of cortisol and the potential emotional effects. So before retention sleep, participants were given placebo or metyrapone, which is the cortisol inhibitor. And what they found was that metyrapone did not affect procedural memory, which was expected, and it generally decreased declarative memory, but it did have a significant increase in emotional text retention. So what this would imply is that increased levels of cortisol during late sleep actually can diminish the emotionality of memories or the emotional significance of memories. And I wanted to ask, what evolutionary benefit could this be? Why may this evolve? Well, essentially it just makes memories less traumatic. It's a coping mechanism. And so these were the figures associated with this specific study. If you look at figure 1 on the y-axis, we're actually looking at the concentration of cortisol in micrograms per milliliter or deciliter. On the x-axis, we have the time scale. And as you can see, as it progresses through each stage of sleep, the solid line, which is representative of the group that received the inhibitor, the cortisol levels are significantly lower through every stage of sleep. And looking at the bottom image, we're now looking at mirror tracing and text. For the mirror tracing condition, we see that there's no significant difference between the placebo group and the group that received the inhibitor. But on the when comparing the emotionality and text, the emotional enhancement was, the retention was significantly higher for the experimental group. So overall, thinking back to the original question, how those concentration levels vary over the course of the night, well, we see the concentration of cortisol decrease initially as the first 4 stages of sleep as arousal decreases. but for REM sleep, we actually see cortisol concentrations increase. And from the literature, we know that during the first 4 stages, the decrease in cortisol allows the hippocampus to store declarative memory functionings of neutral and emotional text. But during REM sleep, the added cortisol actually decreases the emotional impact of memories. Are there any questions?
You said that decreased glucocorticoids allows the hippocampus to store declarative memories.
Yes. Yeah. Glucocorticoid receptors are not active, so the hippocampus is not active.
So the take home is slow wave sleep is helping consolidate declarative and emotional memory, and REM sleep is helping with procedural memory. And cortisol is low in slow wave sleep, but higher in REM sleep. And when you add in a cortisol agonist during slow wave sleep, it interferes with the encoding of those declarative memories, but not procedural memory in REM sleep. Any other questions? Good? All right, Jim, you're up. Officially, over here, go ahead. All right, you're good to go.
Alright, so I did mine, the sex-dependent components, the analgies that were produced by other competition. This is kind of interesting to me because it kind of stood out from the other ones because I feel like being a football player, I hurt myself all the time and I don't even realize it until the next day and I wake up and I can't use my right arm. But basically, analgesia is basically the inability to feel pain, and this is activated in stressful situations. This can come from athletic competition, war, or self-defense. You can see our buddy up there in the right-hand corner, face swollen out there. He probably doesn't feel it in that second, but the next one he will. And it also goes back to a survival mechanism. There's many previous animal studies that have shown the stress-induced analgesia. You can see the zebra right there that got away with his life, got a little chunk of his butt taken out, but he'll be all right. He made it to the next day, but those are the kind of instances that I'm talking about whenever the stress is produced from the environment or a survival situation. And it can be influenced by many different things like age, gender, and like prior experience to the situations. And for this study, they wanted to see the differences between males, females, and along with that, athletes and non-athletes. And they wanted to kind of take apart the athletic part to see if it was more of a cognitive, or if it came from more physical, or if it was from like the athletic competition itself. So they kind of divided all three to see which one had the most prominent effect. And that's kind of my question, to see which one, if it's coming from strictly psychological, or is it physical, or is it both of them together that has the best effect. So the methods, they used a cold pressor test, which is basically putting their hand in really, really cold water. It's not just a normal ice bucket, but it was for a period of 90 seconds. And every 15 seconds, they would be asked to rate the pain on intensity and unpleasantness. And they would do this 2 days before competition, just to get a baseline to see where they were. On competition day, right after they competed in whatever thing they did, and then 2 days after to see if it went up, if it was the same, or if it was different than before. They also measured the skin temperature, just to see if the exercise part might have warmed up their body, and maybe it was helping them with the cold water, and then mood, to see if they related with the stress along with competition, to see if the arousal and that went up in the same rate. And these were the 3 tests that they did. For the psychological portion, they had them play a competitive video game. I believe it was a racing game, just for 10 minutes, just competing against each other. For the physical side, they just had them run on a treadmill for 10 minutes, nothing serious, no competing, just running. And then they had them compete in a track meet. This is where they would compete. I believe there were some incentives in there if they won, so they were really trying to beat each other. And this is kind of the baseline. But they added in that the athletes probably also had lower numbers because they were used to like being in the cold water because of the ice tubs and stuff. But as you can see, the athletes had a little bit lower threshold than the non-athlete. And for the track meet, we can see a decrease in both genders. There really wasn't, well, the males had a little bit lower in the pain threshold. They said it went down, but both athletes and males and females both went down significantly after competing. And this kind of goes along with the mood as well. Both had increased anxiety on competition day, but also it was kind of interesting to note that only the males had increased anger ratings after their athletic competition, and actually the females, the circle right here, the white circle, actually went down. So it's kind of interesting to note that. And this is where things kind of get interesting. So for the psychological and physical part, they found that women actually had a significant decrease in pain after they just ran, and men actually didn't. They actually stayed the same. And then men actually had a significant drop-off whenever they played the competitive video game, and women did not. You can see, I believe this is the women playing the video game. I think theirs actually went up, which is kind of funny, but this is the men playing the video game. You can see how their pain threshold went down, and then the women went down with the black circle. So. And this is also interesting because it was all, they were just reporting off of what they felt. There wasn't actually like any real numbers coming from like their heartbeat or anything like that. They decided to change up the experimenter if it was going to be the same or if it was going to be opposite. And they actually found that whenever the guys were with a female, that they reported that the intensity was high, but they didn't feel it as much. So like trying to be tough, I guess, for the female. But there wasn't, there really wasn't any difference with the female. But with the male subjects, both athlete and non-athlete, you can see they reported that the intensity was higher, and but they didn't feel it as much. So I thought that was kind of fun. So in conclusion of all that, the women had the most significant effects in just the exercise condition, and men happened to tend in both the competitive video game and track meet conditions had slightly lower scores in the unpleasantness, and both had a significant drop in athletic competition. And some future studies I thought would be kind of cool to see if the analgesic effect would be the same between contact and non-contact sports. If they just did it with track, it'd be interesting to see if it would be the same for like boxing, see if they're taming it down. And also with the level and pressure of the game, as we were talking about before, with the anxiety and all that, if that was heightened as well, maybe it had some sort of effect on the analgesia produced, and if it's goal driven, because we see in the athletic conditions that both of them went down for both sexes, so it might have been goal driven in that way. But there's some future things.
Are there any questions for Jen? How does this relate to stuff that we've talked about here between men and women before in stress?
I was thinking about the tend to be afraid of the fight and flight, and how testosterone, you were talking about how like men are more angry, and how like aggression is just represented in different ways depending on sex hormones.
All right. So that was good. We want to leave a little bit of time for questions like that, just to make sure everybody's clear on what these articles covered. I tried to take relatively short articles that you could get through, in 10 to 15 minutes. So if you try and plan your presentations for right around a little under 15 minutes, we should have plenty of time. And if we get out a little early these days, then that's fun as well. So everybody kind of good to go. We had our sort of guinea pigs today. Thank you, Kate, Robert, and Joe, to sort of show us how it's going to work the next week or so. And I guess that's it. If you haven't sent me your question, make sure you do that so I can get that out to everybody. Okay?